This lesson is going to look at the other algebraic method to solving a system of equations. This method is called linear combinations, or sometimes you'll see it referred to as the elimination method of solving a system of equations. This is the steps of solving a system of equations using the linear combinations method. I'm not going to read through them now. You can take a look at them as they are in your notes or pause the video and read them. However, they will make more sense when we actually do an example here in a moment. So let's take a look at these system of equations. I have x minus y equals 0 and x plus y equals 2. Notice that in substitution, we had one of the equations already solved for x or y. We don't have any of those equations here that say x equals or y equals. So that's how we know a linear combination or elimination method would probably be a better idea to use than the substitution method. So step one of linear combinations or eliminations is to make sure your variables are lined up. So your x's need to be in a column on top of each other and your y's need to be in a column on top of each other. In this case, they already are, so step one is done. Step two is you need to make coefficients that are opposites. So if you look at the coefficients of our variables, the x's are 1s, they're not opposite. But the y's, the top y is -1 and the bottom y is +1. -1 and +1 are opposites of each other, so we have opposite coefficients already, so we do not need to create them. So step 2 done already for us as well. Step 3 then is to take the two equations in my system and make them one big addition problem. So I want to make an addition problem and I want to add them together. So x plus x is 2x minus y plus y, those are opposites, remember, so they cancel out to make 0, and then I'm left with equals 0 plus 2, which is 2. So we eliminated the y. That's why it's sometimes called the elimination method. So I can now use this simple one-step equation, 2x equals 2, to solve to find the value of x. So I have 2x equals 2. To get rid of the 2 that is on the same side as the x, I need to do the opposite, which is division, and I want to divide both sides by that 2 that I want to get rid of. So these two 2's cancel each other out. I'm left with x, and 2 divided by 2 is 1. So I know that my value for x, or half of my solution, is 1. Substitute the value of x into one of the equations. It does not matter which equation we choose. Personally, I always choose the one that has addition in it instead of subtraction. That way I don't have to worry about potentially having negatives that I don't want in my solution. So I have x plus y is equal to 2. And every time there's an x, I can substitute it in with 1. So I have 1 plus y is equal to 2. And now I can solve that for the y. So the opposite of plus 1 is minus 1. 1 minus 1 is 0. They cancel each other out. I'm left with y. And then 2 minus 1 is 1. So my solution, or the ordered pair that both lines share, would be the point 1, 1. And again, it's an ordered pair with parentheses on the outside and a comma between the x and the y value. I can then myself for a moment, and I switched to this slide a little too early, but let's take a look at this one. This is a different system of equations. We have 3x plus 2y equals 6 and x plus 3y equals 9. Notice that our variables are lined up. The x's are on top of each other, the y's are on top of each other. However, this time we do not have coefficients that are opposites, so we need to make them. So we have to decide which would be easier to make opposites, the x or the y. By looking at their coefficients, the x coefficients are 3 and 1, and the y coefficients are 2 and 3. I always look at the bigger number. So when my bigger x coefficient is 3, can I make a 1 into the opposite of 3, which is negative 3? And I can make a 1 very easily into a negative 3. So I want to take that entire bottom equation and I want to multiply it by negative 3 so that I create opposites. So we multiply this whole entire equation by negative 3. The top equation I'm going to leave as it is. So when I multiply the bottom equation by negative 3, I would have negative 3x minus 9y, because negative 3 times 3y is minus 9y, equals negative 3 times 9, which is 27. So now I have my x's as opposites, 3x and negative 3x. So now I can go to step 3, which is to make my addition problem. So if I add 3x plus negative 3x, those are opposites, they cancel out, and then 2y plus 9 or negative 9y gives me negative 7y, and then 6 plus negative 27 gives me negative 21. I can solve this for y, but now by dividing both sides by negative 7. Those two negative 7s would cancel each other out. I'd be left with y, and then negative 21 divided by negative 7 gives me positive 3. I can now use my value for y, which is positive 3, and substitute into either one of my equations to get my value of x. I chose to use x plus 3y equals 9. So if I substituted my value of y as 3, I would have x plus 3 times 3 equals 9. If I simplify here on the left, I would have x plus 9 equals 9. Then to isolate my x, to solve for my variable, I would do the opposite of what's here. So opposite of plus 9 is minus 9. So I'd subtract 9 from both sides. 9 minus 9 cancel each other out. That equals 0. I'm left with x, and then 9 minus 9 is 0. So my ordered pair that is my solution is 3, 0. This last example is going to look at what happens if you cannot make the smaller coefficient into the opposite of the larger coefficient. So right now, for step 1 with linear combinations, you have to make sure your variables are lined up. Our x's are on top of each other, as are our y's. So we know that we're okay in that respect. Then we need to look at our coefficients. Our x's are 6 and 4, and our y's are 7 and negative 2. It does not matter which value, x or y, you go ahead and make opposites, but none of them are opposites now, and there's nothing I can take the smaller coefficient and multiply it by to get to be the opposite of the larger coefficient. For example, the larger coefficient is 6 on the x. I cannot multiply 4 by anything to make negative 6. Same thing with the 7. Opposite of 7 is negative 7, and negative 2 times nothing gives me negative 7. So I have to decide if I want to make x or y opposites. I, in this case, would make y opposites because looking at the y values, they are closer to being opposites because remember, opposites are the same number except one is a positive and one is a negative. Right now, we have at least one as a positive and one as a negative. So I would then look at my least common multiple. My least common multiple of 7 and 2 would be 14. So I want the top equation to be 14y and the bottom equation to be negative 14y. So to make the top equation 14y, I would need to multiply the whole thing by 2. So I would have 2 times 6x, which gives me 12x, plus 7 times 2, or 7y times 2, which is 14y, equals 5 times 2, which is 10. Now, I want my bottom equation, the y value, to be negative 14. It's already negative 2, so negative 2 to make negative 14, I multiply each part by 7. So 7 times 4x gives me 28x, and then 7 times negative 2y is negative 14y, and 7 times 10 is 70. I have now created the opposites, 14y and negative 14y, so now we can go ahead and do step 3, which is to create an addition problem and add my like terms. So 12x plus 28x gives me 40x. The y's are opposites, so they cancel each other out, and then 10 plus 70 is 80. I can then divide both sides by 40. I'm left with x, and 80 divided by 40 is 2. So now I can pick an equation, one of the two original. It does not matter. Again, I usually pick the one with addition so I can avoid negatives as possible. So I would have used 6x plus 7y is equal to 5. And every time there's an x, I can substitute it in with the value we just found. So I would have 6 times 2 plus 7y is equal to 5. Now I can simplify the left, so 6 times 2 is 12, plus 7y is equal to 5. I want to solve for the y, so I have to get rid of the 12 first, so I want to subtract the 12 from both sides. 12 minus 12 is 0, so I'm left with the 7y on the left, and then 5 minus 12 gives me negative 7. Then I want to divide both sides by the 7 to isolate the y. Now that the y is isolated, negative 7 divided by positive 7 is negative 1. So that means our solution to this system of equations is 2, negative 1.